Hello, this is Mr. Anksman, and these are your section 6.2 notes on classifying the elements. So the learning goals for this section, we have identify number of valence electrons in an element, and then recognize that electrons are most responsible for the properties of an element, and then distinguish between representative elements, that's group A, and transition metals, that's group B, by electron configuration and location on the periodic table. And then differentiate between cations and anions, and cations are positive ions and anions are negative ions. And then locate these groups on the periodic table and list their general characteristics. Those would be halogens, alkaline earth metals, noble gases, intertransition metals, transition metals, and alkali metals. So let's start with periodic table symbols. The periodic table usually displays the symbols and names of the elements along with information about the structure of their atoms. Sometimes the symbols that you see in the periodic table have a lot more information. Our periodic tables that we use in class are pretty basic. They just have the symbol, the 1 or 2 letter symbol, the name of the element, and they'll have the atomic number and the atomic mass. We don't have anything else on ours, but sometimes you see a little bit more details. And then some tables, they also show the state of matter for the elements. And again, we don't have that, but just so you know, there's solids, liquids, gases. Most of the elements on the periodic table are solids. The gases are found mostly in the top right corner of the periodic table. You have the noble gases, and then you have nitrogen, oxygen, fluorine, chlorine, and then hydrogen is also a gas. There's two elements that are liquids at room temperature. That's bromine and mercury. And the rest of the elements are solid, but then there's also some that are synthetic that just don't exist naturally. All right, and then some names of some of these specific groups. Groups on the periodic table are columns, all right? So the first one we'll talk about is alkali metals. That's going to be the first column on your periodic table, but not hydrogen. Hydrogen is not considered an alkali metal, even though it's in that same column. But the alkali metals are also called group 1A. They're the most reactive metals. They're soft, as in you can usually just cut them with a knife. They have one valence electron, and that means their electron configuration is going to end S1, and they tend to form positive 1 ions. The second group is the alkaline earth metals. That's going to be the second column from the left on your periodic table. It's like beryllium, magnesium, calcium on down the list. That's called group 2A on your periodic table. And those are also reactive metals, not as reactive as the alkali metals, but they will react with water. They have 2 valence electrons, so their electron configurations are going to end S2, and they tend to form positive 2 ions when they become stable ions. The next one is halogens. So halogens, now we go over to the right side of the periodic table. It's the second column from the right. It's called group 7A on your periodic table. And these are very reactive nonmetals. They're the most reactive nonmetals. They have 7 valence electrons, so their electron configurations are going to end S2p5. And they tend to form negative 1 ions when they become stable. The next group we need to know about is the noble gases. So the noble gases, they're also known as inert gases. That's the farthest column on the right. These are not reactive elements because they already have 8 valence electrons, so they're already stable. So their configurations are going to end S2p6. So it has a full electron configuration, it has a full energy level. So they're not going to react. They don't have to change. They're already happy the way they are. So we have helium, neon, argon, krypton, xenon. Those are some of the noble gases. Now we said 8 valence electrons. The one exception to that is helium. Helium only has 2 valence electrons. And then if you put the S block and the P block together, That's called the representative elements. So it's groups 1A through 8A. It's called Group A altogether. And they display a wide range of physical and chemical properties. Okay, and then we have Group A, now we also have Group B. So Group B is the transition metals. So the transition metals is the D block in the middle of the periodic table. It's a little bit lower than the other columns. So the transition metals, they're defined by having the highest occupied S sublevel and a nearby D sublevel contain electrons. So they have electrons in d orbitals, and when you look at their electron configuration, it's going to end d something, so d with some number of electrons. So again, the transition metals are the D block on your periodic table. Okay, and the last group we want to know about is called the inner transition metals. So this is the two rows of elements that are pulled out of the main part of the periodic table and placed below. It's the F block on the periodic table. So inner transition metals have the highest occupied S sublevel and a nearby F sublevel generally contain electrons. So they have electrons in F orbitals, and when you look at their electron configurations, it's going to end F with some number of electrons in that F sublevel. And that's all for the section 2 notes. Have a good day.